Hey everybody, in this video we're going to talk about finding the rate or time in a word problem on continuous exponential growth or decay. So for this problem, we are going to suppose that a number of bacteria in a certain population increases according to a continuous exponential growth model. If we remember that is A equals A naught times e to the RT. Now, usually we're given R and T, and we're given A naught. So in the past, those are what we were being given. And then we were supposed to find A. But now we have a sample of 2,000 bacteria selected from this population, and it reaches the size of 2,549 bacteria. So we have A equals 2,549, A naught equals 2,000, and then it says it took 6 hours. So the time it took is 6 hours. And now we're trying to find the growth rate, or R. So let's go ahead and plug all these in. We'll get 2,549 equals 2,000 times e to the R times 6. How do we solve for R? Well, let's isolate the e that has, or the base that has the exponent by dividing by 2,000. We'll end up getting 1.2745 equals e to the R times 6. Now remember, how did we solve a base e problem? We took the natural log of both sides. So we get the natural log of 1.2745 equals R times 6, because that's the exponent, times the natural log of e. What's the natural log of e? That's 1. So in order to get R by itself, I'm going to divide by 6. And that's just going to give me R on one side. And then I'll do the natural log of 1.2745 divided by 6, and I'll get R as approximately 0.040426. So what's the rate? When we write a rate, we want to write it in percentage. We get 4.04%, rounded to the nearest hundredth. Okay, so we solve it very similar ways, okay? But we just have to make sure we can pull out the right values, the right numbers to go with our equation. Let's go ahead and go over this problem. The mass of a radioactive substance follows a continuous exponential decay model with a decay rate parameter of 7.8% per day. So what is the continuous exponential decay model? A equals A naught e to the RT. So we need to know A naught, R, and T in order to work with this equation. So R equals 7.8%, but it's a decay model, so it's negative 0.078. It says find the half-life of the substance, or the time it takes for 1/2 of the original amount in a given sample of the substance to decay. So we're trying to find time. We aren't given A or A naught, but we do know one thing. We know that whatever time this happens at, the resulting amount, or A, is going to be half of our original amount. So sorry, I wrote that backwards. Our resulting amount, A, is half of our original amount. That's the definition of half-life. So I can rewrite this equation as A naught divided by 2 equals A naught times e to the RT. Now what good will that do? Well, when I divide by A naught or multiply by 1 over A naught, that's the same thing. Those are going to go to 1, those are going to go to 1, so I end up getting 1/2 equals e to the r. I could have plugged in r here. I know what r is. Negative 0.078 times t. Now all I need to solve for is t. So I take the natural log of both sides. I get the natural log of 1/2 equals negative 0.078 t, because I can bring that whole exponent down in front, times the natural log of e. And the natural log of e is 1. And then I can divide by negative 0.078. And after some plugging into my calculator, I'll get t. Well, let's go ahead and write out what t equals. T equals the natural log of 1/2 divided by negative 0.078, which is approximately 8.89 days. So no matter how much of the substance we have, this radioactive substance we have, it's going to take almost 9 days for it to be reduced in half. So that is a video on finding the rate or time in a word problem on continuous exponential growth or decay.